Okay, I'm going to do the easy one first, and certainly look in A. If I looked at that, verifying this graphically is invertible. What I do is, basically look at, is it a one-to-one function, and this has got a slope of -5, so something like this over here. So definitely pass the horizontal line test. What's the domain of that guy? It's all real numbers, right? B is a little more difficult, right? So we'll come back to that. So I want to talk about letter C now. And letter C, looking at it, just kind of graphing it out. If I didn't see the domain of that guy, I would basically say, it's a semicircle, right? So I'm going to say something like this over here. And it goes, I'll put a little axis down here for you. It goes from -4 up to 4. But they say the x is only between 0 and 4. So I'm going to get my eraser out. And I'll put that down for you. What does it look like? It looks like a quarter circle, like this over here, right? It certainly passes that horizontal line test. So I'm going to say this is one-to-one. I'm just visually doing it. What's over here? Well, I'm looking at it. It's a root function, all right? Now, again, a more, you know what? Let's go to F. We'll do the easy one first. So A was really easy. I'm going to say C is easy. I'm going to say E is pretty easy. What's that? That's a parabola. The parabola x squared minus 1 looks like this over here. That's not invertible. But what they said was restrict it to numbers below or equal to 0. So I'm going to get my eraser out, and I'll graph that down. Again, we're visually looking at it. What does it look like? This over here. Now, certainly, does that pass the horizontal line test? It certainly does. All right, let's do the other ones. And looking at it, I'm going to graph them. All right? I know it's tough, but we're going to graph them out. I'm going to go D now. And D starting at 2. And at 2, it would be equal to the number 5. Let me put this down. So at 2, it's going to be equal to the number 5. So I'll put this over here. This is the 0.25. All right, then what happens? This thing starts to decrease. And how do I know that? If you start taking numbers, it goes down and down and down and down. All right, so I'm going to say it's going to do something like this over here. It's going to go down. Now, I realize I'm saying, I wonder what the number is over here. You don't need to know that number, but there is a number that would make that true. If you're interested, the number is actually 27, because 27 minus 2 is 25, and the square root of 25 is 5, and 5 minus 5 is 0. But you don't need to do that. You just need to get a picture of it. So I'm going to say this definitely passes the horizontal line test. So it's invertible. Again, they gave me the 2 to the infinity part. All right, I'm going to say B is probably the toughest one so far. Again, I do not mind using technology to do it. All right, so let me get my eraser out. And I'm going to say I saved the worst for last. All right, it's a tough one. And we're going to graph it. And again, I don't mind using technology to do so. So let's take a look. And if you use technology, which I recommend you do, by the way, I'm going to say that there is a problem at -1/3. And you'll see that if you do graph it. I'm going to say x equals -1/3. If I were kind of looking at this, and again, I'm just kind of looking at sign analysis. I know at 5 it becomes 0. So I'm going to say over here, I'm going to call this, and again, it doesn't have to be to scale. Put this is number 5, 0, right? And kind of just, let me see, like 0, what would you get? Let's see what you'd get there. At 0, you get -5/1. So it's over here somewhere. Again, I'm not kind of drawing this, not great, but I'm going to maybe say something like this now. I'm going to put a solid line in. It goes up. All right, I'm looking at it. Another thing I want to point out is if you're doing this thing, you start to realize there's a line over here as well that this thing rises to. And that line would be y equals 1/3. Again, you want to experiment using a computer to do that. And then this curve over here, this section, looks like this. All right? Now, Grant, looking at it, I know it's difficult. And I'm going to say, just looking at it, I hope you realize that no matter where I draw a horizontal line, it's going to intersect it at most once. So it's also invertible. This is probably the most difficult to understand now. I do recommend you look at technology to graph it out, and you'll see a picture similar to mine. The one thing you're going to be missing in the picture, though, is those dashed lines I got in. They're called asymptotes. We'll discuss that in more detail later. But what I'm going to claim over here, if you were to graph this out, I'm not going to put any axes down now. You're going to see a picture that looks like this over here. shoot straight up. And you see a picture like this over here. Whoops, sorry about that. I didn't do a very good job there. Gotta get rid of that piece. And you're gonna see a picture like this over here. All right? I know it's difficult because a lot of people look at these things over here. I want to point out what I mean by that. They look at these things over here and it almost looks like they're flat or linear, and they're not. They're constantly falling down, but they're asymptotic. They never touch. They just keep getting closer and closer and closer to a line. We'll talk about that in more detail later. So again, this is the only one that I considered really tough. But it is invertible, and you can find an inverse of that. Thank you.